All right, let's see. Boop. Are you going? Yeah. And then 5, 2. Which problem?
27, 30.
There. There we go. Okay, 27. There we go. Intercepts, right? Okay. So we've talked about long division, we've talked about synthetic division. They have more uses than this, but does anyone remember the main thing I sold synthetic division as? Does anyone remember what we talked about with synthetic division? The main thing we're going to use it for is a way to, not a shortcut. It was a shortcut to long division, but factoring. It's a method of factoring. If I can just factor the damn thing straight, I just do it. So, why is the first problem easy as hell? Can anyone tell me the zeros, the t-intercepts?
1, -2.
Yeah, 1, -2, 3. Yeah, if it's factored, you can just see what's going to make it 0. Which is, again, why factoring is so damn important. So why is 27 different, harder? It's not factored yet, so then I have to factor. Now, there's 2 terms. What's the only things it could be? You can either cut everything in blah, or you can cut everything in blah. Boy, who remembers? When I have 2 terms, what methods could I use? Squares, cubes. You do not have a 4th powers rule, right? So can you cut everything in half, or can you cut everything in thirds? Half. So then you do it. Now the trick with this is you can do it twice, because if you do it once, one of the things you're left with will also be a difference of squares. So once you get it all the way factored, you can find the intercepts easy. Yes. What's the y-intercept for this one? What would you have to do to figure out the y-intercept? Yeah, set t to 0, then you have to calculate it, right? Why is this one easier for a y-intercept? If you make x 0, what do you get? Yeah, so when it's unfactored, it's actually, the y-intercept is easy. But I'd much rather have it factored because that's the hard thing to do. So I'll worry about the y-intercept, that's easy. I'll just plug 0 in. It's harder, but not, I'd rather you give it to me factored. But I'm not going to. So. And then 30 is the same thing, except they just stopped 1 too early. Do you see that? You can factor this further. Yeah. Okay. You get this pretty hard? Yes.
Can you go into 5.4?
5.4 number 20? That one right there. Let me see. Okay, so this was the example we did where the bottom is linear, but the first number is not a 1, correct? So synthetic division won't work directly. We have to be careful. Does anyone remember how to be careful? What am I going to put in the penalty box for number 20?
3.
No. Hell no. Definitely not. Nope.
2x squared.
What would I put in there for 22? What would you put in the penalty box for 22? -2. Why? Because it makes it 0. That's another way to look at it. You guys with me? So what goes in the penalty box, and this is very cool with me saying penalty box. When you set up synthetic division, you have the little box on the side, you put a number into it, is what makes the thing I'm dividing by, what makes it 0. Yes? So what makes this 0? I'm sorry, this one. They're both the same.
3.
Nope. 2 times 3 is 6 minus 3 is 3. 3 halves would make that 0. Or you could just equal it to 0, add 3, divide by 2. Do you guys see that? Yes? So in the penalty box, we go through, Somebody with me. We've done examples like this before, but I'm pretty sure we have. Look what I finally got. So what we're actually going to do is we're going to divide by that. So if I synthetically divide by 3 halves, I am dividing by the factor x minus 3 halves. If I divide by 7, I'm dividing by x minus 7. If I divide by 3, x minus 3, negative 11, x plus 11. You guys cool with that? I need you to be with me on this. If I synthetically divide by 2, blah, 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 what factor does that relate to? X minus 2. So if I divide by 3 halves, it relates to x minus 3 halves. Is everybody with me? Which means when I get my answer, I still have to also divide by 2 because I haven't divided by what they wanted me to yet. So that is the trade-off to be able to use the shortcut for something that it's not built for. There's a bit of a trade-off. Okay. You have to remember to divide by that extra number. What else do you have to be careful about, by the way, for this specific problem? Yeah, that's right. There is no x. Right? There is no spoon. So you have to put a 0x in there. Yeah. Or 0 in the right spot for synthetic. Okay, maybe. Okay. Anything else from Homer stuff? Do you have more stuff?
For 5.2, about like intent behavior, like kind of like how the textbook.
Okay. So I told this to my other class, and it's my fault. It's me. It's on me. I have to remember what I tell them. You don't know, but my brain is like, I already said this. I am never, ever, 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 ever going to require you to tell me. Let me see. Later this semester, we're going to do something related to this. But for end behavior, dear God, don't do this shit. What do I want to see when I ask you the end behavior of this? What would you put?
Down there.
Yeah, exactly. You put it down this way, up that way, right? That's all I need. Now watch. Here's the. This is really weird for you to hear from a math teacher, but here's the way too technical way to say this. What happens when x gets really big? When I let x get big, what are the outputs doing? Yeah, so as x goes to infinity, y goes to infinity. Yes? What happens when x gets really big? Negative. That is the way the textbook does it. That's the way you might have instructors try to tell you. If you go to the CISL or the Math Science Center and you want help with this, say, by the way, my teacher don't believe in that stupid shit. Later this semester, we're going to see a much better place to do this kind of thing, and it's going to make more sense. To me, this if I look at that, if I'm going to grade you and I look at this, I have to stop and think, okay, he's got okay, he got it right. Okay, he's got the thing over, okay, he got it right. If you do this, I'm like, bam, I see it, bam, done. You got it right, you got it right. Do you see what I'm saying? So this, it's weird for you to hear this, but this is so unnecessary. This just complicates it when it's not necessary. Later this semester, I will introduce something like this, but it will make a lot more sense. It will actually simplify what we're talking about. Are you guys semi-cool with that? Yes?
So, because I did have both versions of those answers, is having the second
No,
unnecessary one
you're
fine?
fine.
Okay.
Yeah, it's unnecessary. I'm not going to mark you off.
Okay.
And if you like this and it makes sense, do it.
Okay.
You're fine. It's not wrong. It's just unnecessary extra technicality. It's like, come on. So for this kind of problem here, can anyone tell me what the degree would go like? X to the what? Yeah, there's 2, 3, 4. So x to the 4th, is that cool? So then what would you put for me for end behavior? Yeah. Don't connect it because then you're telling me what the middle does and we don't know what it's doing in the middle. It's wobbling.
Yeah. So this is called a problem, and then what, when it is going down on one side and up on the other, that's called what?
So this is called parabolic end behavior. Not necessarily parabolic, 'cause in the middle it could do weird shit.
Yeah.
But yeah, parabolic in behavior, this is what I call cubish.
Okay.
Yeah.
There's no other word for it,
Not really.
or? Okay.
I mean, no, I'll say it like that. There are stupid words, but they're not, who cares?
Yeah.
Yeah, this is parabolic, this is cubish.
Yeah, I think I remember like words and phrases better than I do graph, because, you know, you have an arrow up or
Okay.
down.
I got you. Yeah, for me, the picture's just the quickest way, especially if it's like a negative and then it would have flipped over and blah, blah, blah. So if you try to explain it in words, it gets a little bit tricky sometimes, but you do not need to say as x goes to negative infinity, y goes, you don't have to say all that, that's crazy. I'm sorry, you're good. Teachers default to that, and I disagree with my colleagues on certain things, and it's one place where they could be wrong, it's okay. Sorry. I could be wrong, who knows? I'm okay, I'm open to that. Anything else from homework stuff? Okay, alright, so what I wanna do is I wanna do a review problem of what we've done so far. And then we're gonna move into the next idea. And here, let me see. I'll do two separate kind of review problems. Oh, scheiße. It will wake up. Okay. There, play. In fact, let's do this. No, I'll leave it alone. Okay. Oh, jeez. So I'm never gonna just say, investigate this in graph. I'm gonna have part A, part B, part C. So part A would be like, what's the end behavior? Part B would be, what's the intercepts? Multiplicities, behavior, blah, 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 right? All right. What is the end behavior gonna be like? Cubish, because it's like x to the what total? Fifth. So it'll be cubish. If you just say cubish, it's not quite good enough because there could have been a negative sign and this would flip, and I want to see that detail. So you could say negative cubish and see what I do. I don't know. I kind of like that.
For it to be flipped, what would the equation need to look like?
It would have to have a negative here. Now here's, let me show you an example. So if I put a negative sign right here, then this would have been flipped. Here's an evil way to mean for this to be flipped. Where do you want to put this stuff? Sure. What if instead I had this? What did I have? I think I had this, right? Yeah. Do you guys see that it's really evil? Do you guys see why this would be flipped? Because this is negative x, right? So you would get negative x to the fifth. So that would be the other way around.
Yeah.
Yes? Okay.
Because that would be the leading coefficient.
The leading coefficient will be negative, which means I flip the whole thing over. Yes?
Yeah.
I really want to, this would go like negative x to the fifth, which would look like this, because I would flip it, because the negative is on the outside, I would flip it on the outside of the x, right? Outside the x. So I'd flip it around the x-axis.
And then if we had, so if we had negative x, like within squared, that would go back.
Yeah, now we're getting into territory where you wouldn't necessarily see this, because what would happen then, so now you're saying, what if I had this, like that, right?
Yeah, kind of, yeah.
Well, then squaring a negative makes it a positive,
Right.
so to be honest, this would become this, and then I can put these all together as three of these.
Okay, that's what
Yeah.
I was thinking.
Okay, okay. Okay, I like it. So, can anyone tell me the y-intercept? How do you find the y-intercept? You make You make x 0. So you get negative 5 times 1 squared times 1. So what's negative 5 times 1 times 1? What's negative 5 times 1 times 1? Negative 5. Okay. Okay. So my y-intercept is 0, negative 5. How do I always find the y-intercept? You make x 0. Why is it easy sometimes? Because sometimes there's only one thing that doesn't have an x in it, which means it would be the only piece left alive. I want to make x 0, and I can just see it. That's why mx plus b is the y-intercept, because the other term has an x in it. It would go away. Okay, maybe. What are my x-intercepts? Almost. That's my 0. My 0 is 5. 5 0. 1 0 and negative 1 0. Negative 1 0. 1 0. I like it. Is that cool? The multiplicity of 5 0 is how often does it show up? One time. How often does this one show up? Twice. And this one? Twice. Okay. So pretty with me. We've done a decent amount of these kind of problems. Very quick, I want to point out, do you see why it was easy? Because somebody already factored this for me. Why did we talk about long division, synthetic division? Because you're going to get problems that aren't factored yet, that you can only use factor using synthetic division. So what's the behavior going to be? Stay with me. Through? Bounce? Bounce. Okay. And I'm going to do it a little quickly because we've done a decent number of these. X-intercepts at 5, 1, and negative 1. Anybody see what's good to plug in to give me a little more?
The y-intercept.
I only need, the y-intercept's going to help me. In fact, that's going to help me. I don't need to plug in anything around here because we're going to have these two and the y-intercept. Yes? We already got that. What's something I don't know yet that would help?
3.
Yeah, if I can figure out what f of 3 is, I can tell how high up or down it goes roughly. Do you guys be able to see that for yourselves now? If you plot your intercepts, you see where's the biggest gap of stuff I don't know. Let me figure something out there. So if I do f of 3, that would be negative 2 times 4 squared times 2 squared. Oh my God. That would be negative 128, I believe. Chumbawamba. So what kind of scale do you want to use in the y-axis? Well, what kind of scale should we? Because somebody's going to say, I want to use 1. 1, 2, 3, 4, 5, 6. No. What's a good scale to get me down to 128? 60 might be a little too Fisher-Priceless. That'd be 2 steps to see. Yeah, I'm sorry. It just would be big boom, boom, and there's just 2 steps and I'm there. I want a little more detail.
20.
Let's do, 20s, that's right. 30s would be good, right?
Yeah.
Let's do 30s. 30, 60, 90, 120, 150. So 30, 60, 90, 120, 150. Now what sucks, my poor little y-intercept is 0, negative 5. So he's like right there. Oh no! And if you want to, when you get into calculus, what I'm about to do is going to show up again, just more detailed. I'm going to put a little b next to 1, 0 and negative 1, 0. And that'll tell me I've got a bounce there. And if I don't see a b, I can go through. Yes? Okay. Who remembers what gets me started? Yeah, the first thing we did. So I know I'm going to start down here. And I'm going to come here and I'm going to do what? Bounce. Then I'm going to go here, then back up here, and I'm going to bounce, and then, oh, I forgot to plot this dude, the one we just figured out. Negative 128, 3, negative 128, bounce, go through. Neato. Alright, freaky dog. Now, if you graph this in the calculator, it might go down, lower, but we don't, this is all I want to see. This is the best we can do with what we know. In calculus, you'll be able to figure out exactly where the lowest point is. Here, we just have to guess. It's somewhere in between those two.
What would you use for that?
You would use calculus. Sorry, real quick. I'm gonna, since you asked, can you guys tell me what's the slope right here? Anything about the slope? It's going,
Yeah.
so what's the slope? Negative. Is the slope getting less negative now?
Yeah.
Less negative, less negative. What is it over here?
Positive.
So what is it right there? 0. So doesn't it make sense that most maxes and mins are going to happen when the slope equals 0? Like this max is slope equals 0. This min is slope equals 0. Are there other places maxes and mins can happen? Yes. Do they happen as often? No. But you're still going to have to know. So in calculus, you learn how to find the derivative of any function. And then you set it equal to 0 to figure out where your maxes and mins might happen. That's all I'm going to say about it. I'm not going to let a calculus class break out in the middle of our 171. But it's a good question. It's not that hard. It's not. It kind of makes some intuitive sense. Now the nuts and bolts of how it happens. Okay. But the idea is pretty straightforward. All right. But for us, if we're just estimating. That's great. This is beautiful. This is all I want to see. A really quick way to lose all your points is to do this kind of shit. What do you think that tells me? You put it in your calculator, copied it, and just didn't make y min low enough, yes? You will never get many points at all, if any, for copying from your calculator unless I ask you to. Okay. Oh, yeah, let's finish that one. Good. So, here's the thing. This should be the big motivating factor now. If I have it factored, it's easy. I can find the intercepts. I can talk about multiplicities. But I can do it all, man. I can do this and graph it by hand. It's pretty good.
Yeah.
So if it's not factored, damn it. So some of the problems in whatever section we were talking about are easy to factor straight up. You can just factor them like in the olden days. Yes. But if I had a problem like what I'm going to create right now, everybody just sit there. Okay, this is going to be exciting. F plus 4. I think that works. Let me see. Wait a minute. Yeah, maybe it does work. Let's find out. So what if I have this function here? I think that should work. 64, 32, 96. Does that really work, Jeff? No. Oh, negative. Negative 64. Plus 32 is negative 32. Negative 28. Okay, that works. Okay. Can grouping work? That's what we would try. Can grouping work? No. And I have not told you what to divide by. Now, I think last time, didn't we make lists of possible zeros? Okay. So what's the list of possible zeros for this guy? You guys remember? Possible rational roots. Plus or minus. Where do they come from? Yes, because again, the roots are basically related to the numbers at the end. This is x cubed, so I'd have x times x times x, and then the numbers have to multiply to be 4. So the only possible rational roots would be factors of that. I need this to make sense. whatever numbers are here, here, and here, when I put this in factored form, have to multiply to be 4, yes? So what are those possible factors, possible zeros? What are the factors of 4? 1, 2, 4. All right. Can everybody, do you guys remember how to do synthetic division? Can you guys do synthetic? All right. All right. You ready? I'm going to assign everybody a number to try. You try -1. You try 1. You try 2. Synthetically divide by 2. You try -2. You try 4. You try -4. Everybody else try one of those. Pick your favorite, and you can double check whoever I assigned it to. Go for it. Yes.
So when you're pulling out plus fractions, you only do it with the constant denominator.
If this first number was more than just a 1, then the denominator could be something more.
Okay.
But currently, the denominator could only be factors of 1. So that's the last thing we did last time. So if there's a number out front that's not just 1. Yeah. If that's a 1, then this is x, x, x. And then this is, the zeros are specifically just these numbers. I don't have to worry about
The leading coefficient is to be
1 in order for me to only look at him.
okay.
If the leading coefficient was 3, I have to divide this by plus or minus 1 or 3.
Factors.
And then make all the ratios. Yeah. And then I have fractional possibilities. Let me know if you get one that works. What'd you get? -4? Okay. And you got, somebody got 1? So -4, 1, and oh yeah, we got -4. Any more? Not yet? No? Okay, so let's try this out. So if I divide by -4, so I'm going to put all the coefficients, right? That's the beauty of synthetic division. What gets me started for the synthetic here? Yeah, bring the 1 down.
-4.
Multiply. Good. Add. Multiply. Add. Multiply. Add. So let's see, you also got 1 to work? I'm pretty sure we did one of these stacked dudes last time.
Yeah.
Bring the 1 down, 1 times 1 is 1, add, multiply, add. Sweet. So let's see what we got. What does this relate to? What factor? What factor did -4 come from? X plus 4, yes? That came from x plus 4. Or that relates to x plus 4. 1 relates to x minus 1. And then what is this? It was cubed. The first time we did it, we ended up with squared. And then we did it again, so now we got x to the first power. So what is this? X minus 1. So that's why nobody got it, of course. Jeff, you made the problem. I forgot what it was. I'm sorry. Do you see how 1 worked twice? So if you have a list of numbers to try, did you guys, I'm sorry, if you tried 2, did it come out to not work? You got a remainder, right? The only time you throw something out of your list is if it doesn't work. If it does work, it might work twice, 3 times, 4 times. So what does that mean about 1? What does it mean about the x-intercept 1, 0? What's going to happen at 1, 0? It's going to bounce. So now that's the first step of a problem, and now I can do what's the y-intercept, what's the x-intercepts, what's the behavior, what's the multiplicity. It's going to bounce or go through, blah, 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 everything we just did, yes? Okay, I like it. So some of the first problems you do, it's already factored.
Yay!
And then we go, what if it isn't?
Boo!
And then we learn how to factor it.
Yay!
Okay. So here's the big deal. How long can this list get? Let's see. You ready? Oh crap. Is any of this blank? Yes. What if I had this? Oh, Alright. I have no idea if this is gonna work because I'm just making it up. We're not even gonna divide. I'm just gonna focus on how long the list is. It could factor. You never know. Yes. Okay. So does anyone remember? I have to do a little more than we just did because of one reality about this problem. How do I make the list of all the possible zeros, all the numbers that I could plug into X to make this zero? How do I make that list? Just like we just did, except there's one thing that's different now. So we plus or minus factors of this, yes? That's the same. 1, 2, 4, 5, 10, 20, yes? But who remembers what I have to put on the bottom? It was the last thing we did yesterday. So really quickly, do you remember that problem I had at the very beginning, 2x minus 3? You guys remember 2x minus 3? Do you remember what the zero was? 2x minus 3, wasn't it 3 halves? The 3 was at the end, it's on the top. The 2 was at the beginning, it's on the bottom, yes? Why does that make sense? Because do y'all agree that this has a 6 in front, like this does? Yes? What is the 0 for this guy? 1 over 6. The 1 was at the end, it's on top. The 6 was in the beginning, it's on the bottom. Yes? So, the numbers at the end tell me what could be on the top. The numbers, the factors of the one at the front tells me what could be on the bottom. What are the factors of 6? Yes? So then, is everybody ready? You guys ready? Here's how you put this together. I'm pretty sure we did one of these at the end of class. What I always do is very methodical. You take all of these divided by 1. So divided by 1, they're all the same, yes? Then you take all of these divided by 2, but I don't have to list any, I already listed. 1 over 2 is new. 2 over 2 is old, 4 over 2 is old, 5 over 2 is new. Is everybody with me? What's 2 divided by 2? So I'm not going to list it again. What's 4 divided by 2? So I'm not going to list it again. 5 divided by 2? New. I haven't listed it yet. 10 divided by 2 is 5. I got it. 20 divided by 2 is 10. I got it. Then you start with 3. 1/3 is new. 2/3 is new. 4/3 is new. 5/3 is new. 10 freaking thirds and 20/3. How you guys feeling? Ooh, look at that. And then I do 6. So I get 1/6. 2 6 1/3 I've got already. 4 6 is 2/3 I've got that already. 5 6 is new. 10 6 is 5/3 I've got that already. 26 is 10/3 I've got that already. How long is our list? Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 32. Because there's plus or minus. So I have 32 numbers to check, potentially. If you're unlucky, you're going to have to check all of them until you get to the one that works. Are you guys with me? Now listen. Obviously, I'm not going to make you do that shit. That would be stupid. That would be busy work. You would be able to come up and kick me in the leg if I did that shit to you. Right? That's just me going, hey, do synthetic till you go crazy. No, screw that. So today I'm going to focus on ways to make that list, dear God, Jeff, smaller. Yes? You guys with me? So. One of them is, well, we'll see. No, this is not too bad. Okay. I'm not going to go as deep. All right. Sorry. There's 2 specific ways. One of them, when it works, cuts your list in half. The other one will cut it however, we'll see. The first one doesn't always work. But when it does work, it's like, whoa! And the other one works a lot, it just is not as powerful. Okay. So together, they can make a list like this get really short. So, we might come back to this problem. We'll see. Oh yeah, that's right. We won't, because I just made this ship up out of nowhere. I'll bet you anything none of these work. I'll bet you any of the zeros are like 5 plus or minus square root of 3 over 7. Yeah, you guys kind of understand what I'm saying? If I make something up out of nowhere, I will bet you a lot of money that it won't factor nice at all. Do you understand what I'm saying? And I'm a teacher, which means I don't have a lot of money. So I would bet you a lot of money. All right. So here's the first of the two ways to decrease the size of that damn list so I don't have so many freaking numbers to do synthetic division with, yes? This sounds really good, Jeff. It sounds like a good thing. So let me write down a very specific kind of function here. It doesn't matter. Let's do that. Oh, make that plus. So every coefficient is positive. Well, they asked polynomial. So let me ask you this question. So we already got that written down. Okay, I really want you to think about this. Because your immediate reaction might be, how the shit would I know, Jeff? Is there any positive number I could put into this? And the answer would be 0. Would any positive input be able to make the answer 0? In order for the answer to be 0, what's got to happen? Whatever you got in there has to cancel somehow, correct? What's true about if I put in positive number, what is every number I get? What's true about them? Do any of them cancel each other? Because they're all positive. So could there be any positive roots? I need you, what's a root do? What's a root? It's an x value that makes the output 0. What did we just say? Every positive value I put in would not make it 0, correct? I need you to see why. What's the first one? If I put a 2 in, that's 32 times 3, that's 96. How can I make it 0? I need somewhere to get minus 96 at least. And nobody gives me a negative. How the shit can I go to 0 then? Yes? Is everybody with me? I need you with me. So if I see all the signs are the same in the polynomial I'm looking at, there can be no positive roots. So let me show you concretely what that means. The roots here would be plus or minus 1, 2, 5, 10 divided by 1, 3. I'm going to do this a little bit quickly, right? All the factors of 10, all the factors of 3. 1, 2, 5, 10, 1/3, 2/3, 5/3, 10/3. What we just discovered is I can cut this down to just the negative options, yes? We just figured out that no positive numbers could make the output 0. I cut my list in half. Y'all with me? So I went from 16 things to 8. 8's still a lot. What did 8 frickin' 16? How we doing? How we doing? How we doing? Okay. I love you guys. Does that make sense? Again, I'm trying to find all the numbers that makes the output 0. If I know a family of numbers would never have to happen, I can throw out everybody in that family. No positive numbers work. It could only be negatives. My list has been cut in half. Now, how often are we going to get something where every term is the same sign? Not a lot, but when we do, sweet. And you know I'm going to give you something like that on the test, yes? So what about the opposite situation? What if I had this? Oops, don't skip anybody, Jim. No, Jeff. There we go.
Should it be -4?
Do you see what's happening to the sign? Not only is it not always the same, but do you see how it's always changing? Positive, negative, positive, negative, positive, negative. Yes? You guys with me? So when they are all the same sign, there are no positive roots. When they always alternate, there are no negative roots. Now let's talk about real quick why that's true. If you throw a negative number in to this, what sign is the answer here? What's the negative to a fifth power? Negative. So what sign will this have? Negative. What's negative to a fourth power? So this would still be negative, wouldn't it? It'd be negative times positive. That's still negative. That would be negative because, again, it's an odd power. Negative to a cube is negative. That would stay negative because the negative squared cancels. That would be negative because it's a negative number, and that's negative because 7 don't give a shit what x is doing. Yes? So I got nothing but negatives. Could that ever equal 0 when I put them all together? No, I can't balance my checkbook if all I did was spend money. Yes? So if I got nothing but negatives, I can't make the answer 0. It's exactly the same idea as if I got nothing but positives, I can't make the answer 0. So this is kind of cool. If the signs don't change at all, no positive roots. If the signs do nothing but change, no negative roots. Okay, how are we feeling so far? So obviously they both can't be true at the same time. But when one or the other one triggers, your list is cut in half. Okay. Let me see. Do I want to give you? Yeah. Instead of me trying to make polynomials up on the fly. Oh yeah, I forgot to put this on here. That's right. Oh, we'll do it live. We'll do it live. So let's look at this side first, the one with a lot of writing at the top. So I try to capture, this we haven't talked about yet because we'll talk about it as it happens. But there's, and I forgot to give him props. Do you guys know the name of the XY coordinate plane? The official name of it? Does start with a C. There's a word before coordinate that starts with a C. So it's called the Cartesian coordinate plane. And it's because this guy named Rene Descartes created it, and very quickly. Can you guys suffer through an urban legend story? Sure. There are urban legends in math that would make a very boring movie, but so Rene Descartes was sick in bed. There he is. Look at him. Anybody see him? Somebody in the room? No, in your mind's eye. So there he is. He's sick, right? And he's like, oh shit, we have not invented any antibiotics. But so he's staring at the ceiling, and he sees a fly on the ceiling, and he says to himself, wait a minute, I can track that fly's location using how far left and right he's gone and how far up and down he's gone. He noticed it's two-dimensional. He developed that XY plane. Yes? Rene Descartes. He also came up with this rule I told you about if the signs change or if they never change. Right? So we call that the Descartes rule of signs, because math people are creative. We said Descartes did this, and he looked at signs, and so we call it Descartes rule of signs. Okay. So, first thing I want us to do, I made this a nice problem. Why is this a nice problem in terms of finding this list? Oh, I forgot. This is not the kind of thing. It'll be all right. Descartes' not going to apply here, but we'll be okay. We'll be okay. It'll apply on the back. We'll survive. Okay. I forgot this is focusing on just the bounds. So help me list all of these possible rational zeros. What do we have? 1, 2, 4, 1, 2, 4, 5, 8. So now I've turned the corner. 10, 20, 40. All right. how we doing? That's a respectably large list, right? That's 1, 2, 3, 4, 5, 6, 7, 8, 16. Now, real quick, does Descartes do anything for me? Are all of these the same
No.
sign? Do they alternate signs?
Yeah.
Do they? It was positive, now it's positive. Do they alternate every step? So it's either all exactly the same or nothing but changing. Is it either one of those two? So he doesn't tell me shit. Right? Thank you, Descartes. Sick boy. So we're going to need some help. Can everybody take a moment? And when I say divide synthetically by 8, I literally mean put 8 in the little pellet box. Can you guys try to start doing that? I'll catch up to you in a minute because you'll see what happens. Try to start synthetically dividing that polynomial by 8. All right, let me catch up to you because what's happening? Anybody got far enough? What's happening? Nobody wants to tell me. What's up? They're getting very big. 1, 8 times 1 is 8. 1 plus 8 is 9. 8 times 9 is 72. 72 minus 29 is 43. Is that right? And then 8 times 43 is 344? I think. 344 minus 35 is 309? I think. 8. Okay, now watch. Can you guys see that this is not going to go in evenly? Can you guys see that? Because what's about to happen is I'm going to get a positive, positive, positive. So what I start to do right now, the remainder, I don't give a shit about it. I want a 0 remainder. If I don't get a 0 remainder, I stop. Because I'm just trying to factor this thing, yes? So I put right here, big positive, big positive, big positive, big positive. Is everybody with me? At that point, I don't care about the numbers anymore. I know it's not going to come out to be 0, but here we go. This is related to Descartes' rule of signs. I really want this to make sense. I want everything to make sense. What does this relate to? What factor?
X negative X.
And then all of this crap would be like x to the 4th, blah, right? You guys with me? Same idea as before. Think about this. If I put a number bigger than 8 in, isn't this positive? Which almost doesn't matter. If I put a number bigger than 8, do you guys agree this is positive? And isn't every term in here all positive? I need you with me. Do you remember when all the signs don't change, what kind of number won't work? Positives, right? So here's the trick though. I gotta be a little careful because this is not the problem as it was. This is the result of dividing by 8. What I end up finding is 8 is an upper bound. Nothing above 8 will work. That's what we just discovered. If you synthetically divide by a positive number and the result has signs that don't change, that's an upper bound. Are you guys with me? You guys with me? Okay. So that means if I look at my list, I can take positive 10, positive 20, positive 40 out. I can also take positive 8 out because that shit didn't work.
Yeah.
All right. Now, do negative 8 if you haven't done that yet. I've left myself so much room. And you'll see, you gotta be a little careful about this, but this kind of quickly goes off the rails. 1, negative 8, negative 7, 56, 27, negative 216, I think. Is that right? Do you see how this is going to be big negatives? Do you see how that's going to be big negative? What's big negative times negative 8? Big positive. Then this will be big positive. What's big positive times negative 8? Big negative. So this will be big negative. What did the signs do? Positive, negative, positive, negative, positive, negative. They did nothing but switch. So if I divide by a negative number and the results alternate signs consistently, that is a lower bound. Now this morning somebody had trouble with the word lower bound. It's been a little while, but I remember looking for a place to rent a long time ago. And there's these online things, and you could put in a range of cost, range of rents. Are you guys with me? Has anybody ever done that? You go to like Craigslist, PadMapper, whatever. Yes? So you can tell it like an upper limit to rent, which all of us would probably agree to. I know I definitely had an upper limit. Yes? Can't pay no more. Why would I put a lower limit in? Because what I realized is if I let the lower limit at 0, I was getting like garages and whatever. I'm like, I don't want to live in a garage. I'm not quite that bad off. So I put a lower bound and an upper bound on my rents that I wanted to pay. So I could kind of cut out all the garages and shit and cut out all the places I couldn't even, people wouldn't even invite me into. You guys with me? So lower bound means nothing below this. Upper bound means nothing above this. So can somebody help me rewrite my list using what we know now?
Everything between 5 and negative 5 and 5.
Yes, 1, 2, 4, 5. So my list went from 1, 2, 3, 4, 5, 6, 7, 8. Went from 16 to 8. And Renard, I was calling him Renard in class this morning. Rene Descartes didn't help us at all. We still managed to get it cut in half. All right. So can everybody, let's see. Can everybody pick a number? Can everybody pick a number and see if you can find one that works? Right? So now we know that these are the possibilities, and let's see which ones, if any, work. Yes? Which ones actually synthetically divide into this? You with me? Okay, try it out. Somebody try out 1, 2, 4, 5. I'll try out 5. I don't know. I can't remember what works here. I think 5 works though, now that I say it. Yeah. Yeah, you would do that, Jeff. Sorry. So I got 5 to work. Now, let me stop you for a second. The minute you get something to work, now right now, before I put that down there, we had no idea what worked, correct? The minute you get something to work, this is dead. He's gone. Forget about this. That's the name of the game now. This is the guy that's left. If I ask you to prime factor 48, can somebody get me started? Prime factor 48. You guys remember doing that?
It's like a tree.
Nobody? Huh? It's like a tree. All right. This is making me a little sad. 48. I'll get it started. Isn't this 4 times 12? Does that look familiar? And then what can I do? I wouldn't start over at 48 and go, 3 times. I wouldn't start over, would I? He's dead to me. You're dead to me. Okay, now I'm just going to work with 4. There we go. Now he's dead to me. Now we're working with 12. So bam, 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 bam. Yes? There's my DNA of the number. That's what I call my prime factors. Okay, maybe. So what do I mean by this shit, Jeff? The minute I get a number to work, I am never going to synthetically divide all this shit by anything else because now I've got this. So what does this relate to?
X minus 5.
So that we know. And then what's left, I still have to factor. Now, did anybody else, I'm sorry, I cut everybody off, but did anybody else get another one to work before I cut you off or no? All right. We'll try it live. Let me see if I can do it in my head real quick. That won't work. Let me see. What was going on here? Oh yeah, that's right. We didn't do that. Let's see. Ooh, I think 2 works. 1, 2, 8, 16, 17, 34, 4, 8, 0. Yes. I think -4 might work. I can't remember now. By the way, real quick. Every time you get something to work, by the way, do you see the results here of our division? Do you see how the signs are all the same? You with me? That pretty much means that I'm not going to try any more positive roots. This is the polynomial I'm working with right now. Does anyone know what polynomial this is?
X to the 4th plus 8.
What was the power we started with?
Yeah.
5th. So I divided once, so that would be, didn't I divide once here? So that would be x to the 4th.
Yeah.
And then I divided again, so that would be
X to the
x third. Every time you synthetically divide, you're divided by x plus or minus, you're losing an x. So that was 5, this is 4, this is x cubed. So this is x cubed plus 8x squared plus 17x plus 4. Okay, I need you guys with me. That polynomial, does it change signs? That polynomial, does it change signs? No. So does it have any positive roots? No. So every time you get something that goes in that works, that itself is more information. Whatever's left behind, I can look at it with fresh eyes. I'm not going to try to divide this by 1 because there's no more positive roots that'll work. So let's try -4. 1, -4, 4, -16, 1, -4, 0. There we go. Now help me out. That's x minus 5. What's this?
X minus 2.
And what's this?
X plus 4.
And then what is this? So let's see. 5th power, 4th power, 3rd, 2nd. So this will be x squared
4x
plus 4x
plus 1.
plus 1. Now, is that fully factored? Can you factor x squared plus 4x plus 1? Can you find numbers that multiply 1 and to be 4? Not whole numbers, not nice integers. There are numbers that do that. We're going to actually find them, but I can't see them directly. Can anybody see them directly? If you can, teach me. Okay. Let me stop for a minute, you guys. When you get to a quadratic, I don't need synthetic anymore, because if it's factorable, I can factor it. We can factor every damn factorable quadratic, can't we? Do we do the AC method if the first number is not 1? Okay. Now, but how do I find the zeros? Can you guys tell me the 3 easiest zeros? I didn't even need to write that shit down. What are the zeros? 5, 2, -4, right? There's 2 more zeros. How do I know there must be 2 more zeros? What was the power of the original problem? What was the degree? 5th degree. Fundamental theorem of algebra says there has to be this many intercepts. You could have some that repeat. I don't have any that repeat in my face up here, right? So I have to have 2 more answers. I must, because I've only got 3 so far. So how do I find the other answers? I can't factor this shit, so what do I do instead? What do you do when you can't factor something you're trying to make it equal 0? What lives, whose purpose is to solve ax squared plus bx plus c equals 0?
Whoa.
Quadratic form, yes. All right, go for it. I want you to do quadratic formula to this guy. Figure out the last two answers. Good catch. Alright, anybody getting that? Should get some gross square roots done. Alright, I got this. After some simplification. So that's what it looks like from quadratic, right? Negative b plus or minus. Yeah, okay. And then 16 minus 4 is 12. Square root of 12 is square root of 4 times square root of 3, which is 2 times square root of 3. And then I can divide everybody by 2. So now, this is how many answers? How many answers is this? 2 plus or minus is negative 2 plus this, negative 2 minus. So that's 2, 3, 4, 5. So I have 5 zeros, which is how many I'm supposed to have. Okay, now, I want you to do the other side. Go for it. Call me or Christina over if you need some help. I might try to put you into groups eventually if you don't kind of Alright guys, I'm gonna start to catch up to you. So for this first one, what's nice about this in terms of finding the list? Oh, by the way, what is rational number? What kind of a number is a rational number? What's the root word of rational? Do you guys know what a root word is? Like the heart of it? Rational. What's the root word? What's the heart of the word rational? What's the first part of the word rational? Ratio. What kind of numbers come to mind when I say ratio? So, rational numbers are any numbers that could be written as fractions. So is 3 a rational number? Yes, because you're going to write 3 over 1. Yes? Is pi a rational number? No. It's just a non-repeating decimal. I can't make that into a fraction. Pi over 1 is not a fraction because a fraction is officially an integer divided by an integer where the bottom is not 0. You guys with me? So all a rational zero is, it's numbers that make the output 0, but they have to be fractions. Or you can write them as fractions. So while the answers, a 0 could be 2 plus rad 3, that's not rational. It wouldn't show up on my list, thank the gods. Do you want to include all the possible irrational? No, I don't. Okay. So what's nice about this one? In terms of finding the list of possible rational roots, what's nice about this one? Is there anything nice about this poor guy? He's trying. Anything nice about it compared to him? Why is this one worse? Not just because it has more terms. I almost don't care about the terms. Why is this one nice and this one's worse?
There was no number at the
Yes, there's a 1 out front. Yes? So am I going to get any fractional, like purely fractional answers? No. So what's my list going to look like? 1, 2,
3,
3,
4,
4,
6,
6, 9, 12, 18, 36. Now, real quick, I don't think I told you guys, but some of you guys, well, we'll see. Do you guys see how there's like a turnaround point? Once you get past a certain number, you start to pair it up with numbers that came before. What's the square root of 36? That's the turnaround point. Now, if that number is not a nice whole number, like not a square number, what's the square root of 40? A little more than 6. So around 6 should be the turnaround point. That's kind of good to know. This shit you gotta think. This shit you don't. Because you just pair it with what came before, yes? So it's good to know, when can I stop thinking, please? Yes, that's good to know. Okay. So this one is a bit freakier, because not only do I have that, I got this. So what's going to go on the top?
1,
Yeah, 9. I don't even worry about square rooting it because it's just freaking 139. What about the bottom?
1,
2, 3, 4. Yeah, 4 is my turnaround point, right? 6. Not even 4. 3 is 4, 6, 12. Yes. And now I've got to make all the possible ratios. So it'll be 1, 3, 9. I take each one and divide it by 1. Take each one and divide it by 2. Take each one and divide it by 3. But 3/3 I've got, 9/3 I've got. Take each one divided by 4. Oh my God. Take each one divided by 6. 3 6s 1/2 I've got. 9 6s 3/2 I've got. Take each one divided by 12. 3 12s is 1/4 we got. 9 12s is 3/4 we got. So that's my, oh my God. That's my, oh my God. That's my list. How many things are here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 24 things. So, looking at this, and you notice how I made it the same problem. What do you know using Descartes' rule of signs? I'm sorry. Yes, that's the one. What do we know is going to happen here? What am I not going to have any of? What kind of zeros? What kind of roots am I not going to have? Are there any sign changes in it?
No.
So what kind of roots am I not going to have?
Positive.
There's no positive roots. So then I can go back to my list and cut out all the positives, cut it in half. Yes? So there's no sign changes. No positive roots. What happens on part B? The signs
Are alternating.
always change. They're alternating. So what does that mean? What's it mean when I have nothing but changing signs? I have no negative roots. Okay. All right. So 3A is another example of a semi-gross one here, right? Thankfully 8 doesn't have too many things here, and 3 definitely doesn't, but I still get some fractions, right? 1/3, 2/3, 4/3, 8/3. Yes? So I still have kind of a big list. Does Descartes help out at all? Does Descartes help out? If I look at my given polynomial, what's it doing? It's always changing. So be really careful. Every time you go one more term, it's got to change sign. If I had plus, minus, plus, plus, minus, plus, nope, didn't work. It wasn't changing always. It's got to change every single time. So since it's got only alternating signs, what do I know? No negatives. Which means my list becomes just positives, yes? Okay. And normally I would have a part C that would say update your list, but yeah, okay. What about this one? Did anyone do this? Where'd it go? 3, -7, 14, -28, 8. Don't be ashamed to use a calculator when these numbers get kind of big, but 3, 12, 5, 20, 34, big positive, big positive, big positive, big positive. You guys see, I can kind of see when it's just gonna kind of skyrocket it. You know, I don't have to worry about the exact numbers, because I know it's not gonna be a 0. But what do I see now? In my answer, did any signs change? So therefore 4, it's a positive number, I divided by a positive number, and the signs didn't change in the result. What does that mean about 4? Upper bound. Did 4 work? If 4 worked, what would be here? 0. So did 4 work? Did 4 work? No. So I could throw 4 out and everything above it. So what does my list look like now? 1, 2, throw out 4, throw out 8, 1/3, 2/3, oh, not plus or minus, sorry. 4/3, 8/3. Okay, still, there's 6 of them there, right? This is why I was asking you if you wanted to check in with people to see if they got one to work, because there's still 6 things they got to check, yes? Did anyone find one that worked?
2.
2 works? Okay, so everybody who didn't find one, do 2 real quick. Where'd it go? There it is. Woohoo! Now, let me see if anybody, alright, let me see if anybody could see this. Synthetic division kicks ass, yes? Maybe? I don't know if you guys work with me on that. But if I didn't have to do synthetic, that would be good, because I have to kind of guess, and I'm gonna make mistakes, I'm gonna get ones that don't work. Does anyone, can you tell me what the results are so far? What did we get to go in? What is this? X minus 2. What are the results here? Yeah, because it was 4th power. So now it's going to be 1 degree less because I divided by x something. So it's now it's a 3rd power. Minus x squared. Does anyone see, oops, yeah. Does anyone see what I could do here? How many terms are there? 4. What would I try? What would I try? 4 terms. I try grouping. Do you see how this is 3, 1? Right? You can see here 3, -1. And if I took a 4 out of this, wouldn't it be 3, -1? I can see that grouping's going to work, because if I take stuff out, I end up with the same thing, which is when grouping works. My result in each piece has to be the same, then I can take it out. I don't have to do synthetic anymore. So sometimes you can always stop at a parabola, you can always stop at a squared. Because we can factor every single one of those as factorable, we can factor it, no help needed. But I could stop at some 3rd powers if grouping will work. And right here, when I saw this, I was like, oh shit, grouping's gonna work. Because it's 3, -1, and that's 4 times 3, and that's 4 times -1. I could factor 4 out, blah, 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 blah. All right, so if you haven't done that yet, go ahead and try to group that. Factor that bad boy. Let me see what comes out of these 2 here. What comes out of these 2? be left with?
3x minus 1.
Good. Now what comes out of these two? 4. And I'm left with?
3x.
And I know I'm in the right track. So this will be, the x minus 2 is just sort of out there. 3x minus 1 can come out. Oops, sorry. And then I'm left with x squared plus 4, yes? If these two are not the same, you've either made a mistake or it's not factorable. These two have to be the same to be able to go to the next step. What are my 2 roots I can see right now?
2. And
Add 1 divided by 3? 1/3. What was the power of the original problem? It was a 4th power, right? So how many answers am I supposed to have? 4 answers. Now some could be repeats. None of the ones I have so far are repeats. What are my other 2 answers? How do I get my other 2 answers?
get to be factory x squared 9 plus
Sure, I love it. You could factor this. Does anyone know how to factor this?
squared.
Or can somebody really tell me where you got 2 from? Why do you say 2 was the answer? Anybody? You're right. This is part of the answer, but why? Because it makes this 0. So I'm curious, what makes this 0? Well, let me just say, what makes this 0? Now solve it.
2.
No.
Oh, negative.
4 plus 4 is not 0. Look what I could do. What's the square root of negative 4?
Plus or minus
2i. So some answers can definitely be complex, yes? Okay, in fact, let me do one more thing here. So if I want, how did I state this? Up to you, let's find all the zeros. Find all the zeros, every single one. So I mean real and complex. So here, I want to do one more thing with you guys. I want to show you this. This is so cool. Let's graph this dumb thing. Poor little polynomial didn't even want to exist, and I'm telling you it's dumb. I'm so mean. Where'd it go? Oh my god. Is that the one we're doing? Wait, am I in the same one? No. Okay. We're doing this one. 3x to the 4th, that one, right? Yeah. 3x to the 4th. Minus 7x cubed. Plus 14x squared. Where'd it go? Minus 28x plus 8. If I zoom out a bit. Oh, did I forget somebody? Put your glasses on, Jeff. Put your damn glasses on, Jeff. Okay. 3x to the 4th minus 7x cubed plus 14x squared minus 28x plus 8. Yeah. Holy crap. Somewhere, so I can only see 2 real answers here, right? There's the 1/3, yes? And there's the 2. Now somewhere, I don't know if I'm gonna find it. You guys are gonna go a little crazy. Damn it, I don't see it. It's okay. We'll be okay. Man, I'm upset now. Alright. Somewhere, the scale is just crazy for this one. But somewhere, I'll bet you anything, it does this kind of thing. Do you see how if this was lower, it would actually go through the x-axis, I would get 2 more real answers? But since it's higher, the answers I would have gotten become complex. And remember, that's the thing from the video we watched where you pick it up and then it actually hits, but just at a different dimension. All right, let's not worry about that. I'm not going to graph that. Bunch of colors. Yeah. Anyway, okay. All right, that's plenty for today. Is anybody upset about that? Complain to my dean if you think I'm not giving you your tuition's worth. Actually, I had somebody do that once because I let them out early like twice. So feel free. My dean wants any reason to get rid of me, so go give him something. Oh, I said that on camera. I should have said that. Sean, I love you. You're awesome. Okay.